Welcome to the Banker Lamp. Please enjoy the video.
You start by verifying the Azure Latch model and firmware because compatibility prevents binding. Connect the 12V DC supply next, making sure ground is secure. This stabilizes control signals. Mount the latch to a simple jig so the spindle can rotate without obstructions and align 5:1, 0 centimeter clearances. Then actuate a single slow pulse to the drive. Watch movement closely, because early feedback tells you if bearings or alignment need immediate correction. Once you see smooth motion, proceed to controlled spin sequences. Once initial movement is confirmed, apply a controlled PWM ramp. You begin at 10% duty and raise it in 10% steps every 3 seconds, because gradual acceleration reduces stress on gears and bearings. Make sure to monitor current draw and listen for irregular noise. Stop immediately if current exceeds 1.5 amps or if grinding appears. After each 30-degree rotation increment, inspect alignment and clearances, and correct any drift. This prevents cumulative misalignment as speed increases. When stable, move to full operational speed testing. You finish by running a full-speed spin test for 60 seconds while logging RPM and temperature, because that verifies sustained performance. Then secure all fasteners to the 2.5 Newton-meter torque specification and add thread locker where vibration is present. If the latch stalls during testing, reduce the mechanical load immediately, realign the spindle, and inspect bearings for wear. These steps address the most common failures. Finally, repeat the controlled acceleration sequence to confirm the fix and document settings that worked.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.